Good morning, dear students. So, as in the previous video, we have seen one form which is relating to the form as 1 upon a b sin x, or 1 upon a b cos x, 1 upon a cos x plus b sin x, or maybe the tan x. So those forms we have seen. Now we are going to head to the new form, or the new thing, that is called the integration by partial fraction. Okay, now partial fraction would we'll just understand the meaning of that partial fraction, but first let us see what is the introduction of this topic. So first of all, just listen what I'm saying. A function of the form fx upon gx, where fx and gx are the polynomial function, where your gx shall not be equal to 0, then this is called the rational function, which you already know. Now what happens that sometime, or at some of the point of time in the integration, you will see such type of case where you have some function of fx in the numerator and some other function of x in the denominator. So it would go somewhat typical for us to solve if we go with the general method of integration, like substitution or maybe the direct integration. So what we do, we decompose this rational function in a very simplified manner, and we come up with the new thing that is called the partial fraction. We divide these two in such a way that we can easily integrate both of them. So that is what concept we are going to use for dealing with this such type of function, that is called the rational function. Okay, so I'm just writing that how and what type of rational function you have, and how we can write it into the partial fraction type. Okay, so here you have the things what we are going to see, type of partial fraction. So let me just give you one a short introduction that what I've written here. So as we resolve the proper rational algebraic function into the partial fraction as you have here, so first factorize the denominator in the proper rational algebraic fraction into the real factor, which may be like in the following types. So just try to understand. If you have such type of case where you have px plus q upon x minus a into x minus b, you can split that in two as a upon x minus a plus b upon x minus b, where this capital A and capital B are only the constant values. Okay, so such type of form is called the linear non-repeated. This is called the quadratic non-repeated. This is called linear repeated, and this is called quadratic repeated. So this is linear not repeated, quadratic not repeated, linear repeated, quadratic repeated. So in such type of four cases, you have to use their respective partial fractions. So if you have such type of case, then you have to use this. If you have such type of quadratic case and in the denominator three factors are there, so a upon x minus a plus b upon x minus b plus c upon x minus c kind of. If you have this linear but the repeated case, repeated means actually this is x minus a into x minus a. So it will be a upon x minus a plus b upon x minus a square. You have to use whole square. If you have this repeated, this in the quadratic, this is quadratic, and this is we can write this as x minus a and x minus b. So a upon x minus a plus b upon x minus a the whole square, the same as of we have used here, and this will be plus c upon x minus b. And this is a mix-up case, we can say quadratic upon this one. So a upon x minus a plus bx upon bx plus c upon. One more case is there, I have not written because of lack of space, that is px cube plus, you can see from the book, okay, the last form of that particular chart. Now keep this in mind and let us go to the questions. You have to remember this. I think it is not a very tough task for you to just remember this thing. If you will do the practice of this question, no, automatically it will fit in your mind, and you can know that what type of partial fraction will be used in such and such question. Okay, so here is the first question. Integration of dx upon x plus 1 x plus 2, the very first and the very basic question I'm starting with. Given, let us take 1 upon this x plus 1 upon x plus 2 is equal to a upon x plus 1 upon plus b upon x plus 2. Now you just have to see that with what type it is matching, and similarly we have to use that particular form of it. So it is matching with our first form, that is px plus q upon x plus a into x plus b. So that is what, a upon x plus 1 plus b upon x plus 2. Now this is as it is, take the LCM, so we'll get like this. We can understand that these two will be getting cancelled, so don't show that they both will cancel. We just write 1 equal to, multiply this ax plus 2a and bx plus b directly. From both I've taken x common, so 2a plus b here. On comparing the coefficients, do we have any coefficient of x here? No, so that is why a plus b equal to 0. And on comparing 2a plus b with this 1, so here take b that side, so a equal to minus of b. Substitute the value of a as minus of b plus b equal to 1 minus b equal to 1, b equal to minus of 1. Similarly, a will be equal to minus 1, that is 1. Okay, so put in this equation, in place of a we have put 1, and in place of b we are putting minus of 1. Okay, so it will be 1 and it will be minus of 1. So in place of this we can write here this one. So that is what we have replaced this with, this 1 upon x plus 1 minus 1 upon x plus 2 dx. Now it is very easy for us to integrate. What is the integration of 1 upon x dx? Log x. So the integration of this is log x plus 1 minus, the integration of this will be log x plus 2 plus c. Okay, this is the final answer though. So that is how you have to do. Okay, now just please try to understand this question. This is somewhat of different taste. If you have the question, integration of x square plus 1 upon x square minus 5x plus 6 dx. Now this is not matching with any of our partial fraction which I have written. So first of all, what I'm doing, I'm dividing this with this. So x square minus 5x plus 6 is being divided by x square plus 1. So with 1, so we'll get x square minus 5x plus 6. This x square is cancelled with x square minus plus, so that is why plus of 5x I have written. And 1 minus 6 will get minus of 5. So can we write this expression as the quotient plus the remainder whole upon the divisor? So we'll get, after solving this, we'll get this one. Okay, so you can write like this also. If you are given fx upon gx, then you can write this in quotient plus remainder upon gx. Now why I have written so? To get this in the simplified form, because integration of 1 is what? The x, and this integration we know this is of form px plus q upon x minus a x minus b. See, this x square minus 5x plus 6 have split. I've just found the factor of it, because this is a quadratic equation, so x minus 3 and x minus 2, and from here I've taken 5 common, so x minus 1 upon x minus 3 into x minus 2. Now I've used the partial fraction, the application of partial fraction here. Okay, took the LCM, and I've just taken all the coefficient close, and I've taken common also. So x minus 1 equal to a plus b times of x minus 2a minus of 3b. On comparing the coefficient, a plus b equal to 1 and minus of 2a minus 3b equal to minus of 1 coming. I've taken minus common and cancelled with this minus, so I got 2a plus 3b equal to 1. This 3b I'm writing it as 2b plus b equal to 1. I've taken 2 common from these two, so 2 times of a plus b equal to 1. We have a plus b equal to 1, so I've substituted the value of a plus b. So 2 plus b equal to 1, take 2 that side, so b equal to minus 1. So from here a minus 1 equal to 1, so we got a equal to 2. Now put in this one, so in place of a we can put 2, and in place of b we are putting minus 1, so it will be like this. Don't solve it, otherwise you will get this only. Okay, that means in place of this integration we can put this one. So what will be the integration of whole? The first of all, the integration of 1 is what? X plus 5 times of integration of, just understand that integration of this is 2 upon x minus 3 will be 2 times of log x minus 3 minus the integration of this will be log x minus 2 plus of c. This is the final integration. So that is how you have to understand and do the question. I have only explained you only the 2 questions. In the next video, will, if possible, will give 1 or 2 videos on this exercise only or on this topic only. The only thing is you should understand this topic or concept very nicely, because it will help you in the future also. In engineering or in the BSc field, these questions, these things you have to, that means understand it very nicely. Okay, so in the next video we'll come up with more questions, some typical questions. Till that, do the practice and just see the examples first, and write all this basic things in your fair copy especially. Okay, and do some 4 to 5 examples starting, and like 4 to 5 questions of this exercise, so you will get some confidence of doing these questions. Okay, so I hope you'll do it. Thank you so much. Have a nice day. Bye bye.